Hi guys, and welcome back to another lesson in Algebra 1. Today's lesson is Unit 3, Lesson 9. This is going to be day 2 of working with problems that are either discrete or continuous functions. And then once we decide whether it's discrete or continuous, we can figure out the domain and range of that. These are word problems, so they're real life scenarios. And word problems can be challenging because you're trying to figure out, of course, all the components to it. If you want to see the day one, that video will be listed, before this one on YouTube. Don't forget, domain is going to be the value of all the possible answers in the horizontal direction on the x-axis. And the range is going to be all the possible answers in the y-axis. Okay, so let's go ahead and remind ourselves what discrete and continuous mean as it applies to math. So a discrete function, this is going to be a function that has individual points. There will not be a line. It will be, just individual points, and they're not connected in any way. This is different from a continuous function where there will be either a line or curve, and the data will be all connected. Now, why it's important to know the difference between these is because it affects how you write them. So if we had a discrete function, which remember are individual points, we would write either our domain or our range in this format. Okay, we would list out all the possible values that x could be, and we would list out all the possible values that y can be. That is different than continuous, because continuous is a line or a curve. All we have to do in that case is we're going to identify the low value, and then we're going to identify the highest value, and you put either the x or the y in the center, and then you have your inequality signs. So we write our domain and range differently depending on the type of function. That's why it's important to identify, is it discrete or is it continuous? Because it affects how you write your answer. Okay, so let's go to the next part. It says continuous function. You're going to identify. Let me make sure I got my writing thing. We're going to identify the lowest and highest values. Okay, so you're likely going to have to calculate these. Okay, so remember, we're identifying the lowest and the highest because this is what we're writing here. We write the low and we write the high. Discrete functions, what you're going to do is you're going to identify all possible values for domain and range. Okay, so it's not going to be just identifying the low and the high. You're going to identify all the possible values because they're individual points. And you would list them out when you're writing out your domain or you're writing out your range. You may need to end up creating an equation to calculate your values. Sometimes the problems give you an equation, and sometimes you need to create it based on the words that are in the problem. And then I would highly suggest that you create a data table. Create a data table to organize your work. And by that, I have this example over here that my sloth is looking at. I would put my domain over here on this side, all my possible domain values. I've got these y's that I'm going to calculate based on some sort of equation that we're going to end up writing out here in the middle. And I'll show you what I mean. And again, this is a continuous lesson from the last lesson, so it's building on what we've done and giving you more practice. So if you need more help kind of getting oriented to what this topic is, I would step back and go to the prior lesson and see if that helps you, figure out what everything is from the very beginning. All right. So we've got an example here of Noah flying a drone. And we can see the path in the graph. So we can see that the drone, it started down here at 0, and it's gone up in the air, and then it's lowered, and it's gone up, and then it's lowered, and it's all the way landed again. Over here, this is going to mean when we've landed after all of our flight, and this is going to be where we started. And if we're thinking about our graph, this is going to be the highest of where this drone is going to fly. And so remember, if we're thinking about our domain, we're thinking about all the possible values between here and here. And if we're thinking about our range, we're thinking about all the possible values between here and here. So it says, what is a reasonable domain and range for this situation? I'm going to go ahead and make myself a data table because it helps me to organize my thoughts. So let's think about where we are starting out at. Okay, and in this case, I can also think of this as my lowest value. It might not always be your lowest, but in this particular graph, it is our low. Our time down here, I mean, this is going to be 0, right? It's starting. Let's see, we've got time. That is on my x axis. And then we have height. And that's on my y. When we start, and then let's see, we're going to do highest. We'll do highest for this part. I'm starting at 0 time. And it's going to go, when we look at this x direction, my highest value is this 5. Okay. If I look at my height, that's in this direction. My lowest, again, is going to be that 0. Okay. And then my highest, I'm going to go ahead and call that 50. It's, you might could guess that it's something a little less than that, but I'm just going to go ahead and call it 50 for ease of this. Okay, so now that I know where my low and my high is, I can write out my inequalities. So this is a continuous function because it's got a curve. So I know that I'm going to write this in this format here. I'm going to write my low value, my high value. I'm going to put either X or Y in the middle, and then I'm going to put my inequality signs in there. So let's start at the beginning. I've got my domain, and my lowest value of my domain is 0. My highest value of my domain is 5. And my domain is this guy here. Okay, it's time. My low is 0. My high is 5. I wrote low is 0, high is 5. It is the x-axis, so I'm going to put x in the middle. Now, it can be exactly equal to 0, and it can be exactly equal to 5. So I can put less than or equal to 0 here. X is less than, or x is greater than or equal to 0. And then we can put this where it can go all the way up to 5 and be equal to 5. And x is going to fall anywhere in between those, including 0 and including 5. That's what those inequalities are telling me. Let's look at range. And so remember, range is going to be, it's going to be my y. So we're looking at starting down here, and the absolute highest that it can be is up here at 50. And that's what we wrote here. We wrote 0 is my low and 50 is my high. So when I write this out as an inequality, I write my low value, that's at 0. I write the high value, The range is dealing with the y, so I'm going to write my y in the middle. That y can be exactly equal to 0 or greater than it. And then it can be exactly equal to 50 or, less than that. So what this inequality is saying is that my y can be anywhere from 0 to 50, and those equal signs are telling me that it can equal exactly 0 and equal exactly 50, as well as all those numbers in between. Okay, so all this work here, this is my actual answer, this pink box. This is what we were looking for, that everything else was scratch work and getting organized. Okay, so the pink box is my answer. Let's look at this next one. So if I'm going too fast, just pause it. It says a school band is ordering box lunches for a competition. There's a $60 setup fee and $6.25 per lunch. They plan to order between 145 and 148 lunches. Okay, let's stop to think about this. Over here, this was a continuous line. We could have any kind of values in between. There's no way to have values in between. You're either going to get 145, 146, 147, or 148 lunches. There are no, so, I can even write myself a little note here. This is going to be a discrete function. Because you can't have 1.2 lunches. Okay, so that's why we know it's a discrete function. We have to stick only to those numbers that it gave us. So let's go ahead and think about what it gave us. Well, I'm going to go ahead and make this here. I'm going to start this. I'm going to put x. My x is my first value. And they're telling us that they were going to order lunches between 145 and 148 lunches. So the number of lunches is what's going to go in here for x. Your lunches. Okay. I can have 145. I can have up to 148. And so I'm going to just keep writing 146, 147, 148. Those are my only 4 options for lunches that they gave us in this problem. And then the number of lunches is going to determine the cost. Okay, so we're looking for dollar values. It's going to determine my cost. That's going to be my y. So I can go ahead and leave this blank for right now. I've got to do all these calculations. Well, how am I going to calculate that? Well, in order to calculate it, we got to go figure out what our equation is. So I read that there's a $60 setup fee and $6.25 per lunch. That's telling me that my equation is going to be $6.25 times, the number of lunches. Well, lunches is X. So I'm going to put $6.25X, and there's a flat fee of $60. That's going to be what we're going to be solving for all of these. So every time I see this X, I'm going to drop in the X value that I see there. So the first one is 145. So I'm going to write 625 times 145 plus 60. And that answer, as it turns out, is going to be 966.25. Already calculated them ahead of time, so I wouldn't have to haul out my calculator in the video. We could do that again. So we did the 145. We could figure out what it is for 146. So I'm going to do 125 times 146 plus 60. And that's going to give me 972.50. I can plug it in for 146. So 625, 147 plus 60. 147 lunches. When I do this math here, 147 lunches is going to cost me $978.75. And then I can do it for my last one, 148. So I got 625 times 148 plus 60. So 625 times 148 plus 60, calculating that out is going to give me 985. Okay, so what this was asking for is it's asking for, let's go back and read our problem. What is a reasonable domain in range for this situation? This problem, what we just calculated is if we buy 145 lunches, it's going to cost us $966.25. If I bought 146 lunches, it's going to cost me $972.50. And then if I bought 147 lunches, it's going to cost me $978.75. And if I bought 148 lunches, it's going to cost me $985. That's what we did here with this data table. This data table is only my scratch work. So my answer is going to be when I go write the domain and range, because that was my question. So my domain, because this is a discrete function, we are not going to write it. We don't write it like we did over here. Okay. Discrete functions, we write like this. We list all the values out. That's why we had to figure out what each of the four values were. So my domain, I'm going to list those out. I'm going to put my little curly brace here. So I've got 145. Okay, I checked that one off. That's good. 146, 147, and 148. That's the shorthand way of saying those are the four different numbers of lunches we can buy. My range is going to be all the four costs for those four numbers of lunches. So I've got $966.25. I have $972.50. $978.75. And then $985. Those are my four possible costs that I just showed here. So the answer that we are looking for, this is the answer that they were asking us to find. This pink box is the answer to the question. Everything else that's outside the pink box, that was our scratch work in getting ready to answer that. So pink box is the answer. Everything else is the scratch work. All right, let's look at this one. We have a printing company charges a flat fee of $18 plus $3.40 per poster. The cost function is this. Oh, yay, they gave it to us. So we didn't even have to figure it out this time. That's awesome. Where X is the number of posters printed, and the company will print between 45 and 48 posters, what is a reasonable domain in range? Alrighty then. Okay, it told us X is my number of posters. So we can write that down over here. Our X is going to be number of posters. Now, we cannot have partial numbers of posters, right? We can't have 45.5 posters. So this is a discrete function, which means we're going to have to list everything out. Okay, we're going to have to figure out how much it costs for 45 posters, 46 posters, 47 posters, and 48. How are we going to calculate that? We're going to use this equation that it gave us. 18 plus 340x. And so what is my y? Well, my y is going to be cost. Okay, so you're spending 18 as a flat fee, and then it's 340 per poster. The C of X, that's cost. That's what that is. So anywhere we see this X, this X right here, we're going to drop in whatever X value is over here. So my first one is 45. So I've got my flat fee plus 340 times 45. And I did the math ahead of time. That is going to give me $171. I put a dollar sign here because I wanted you to see these numbers mean something. Okay. The next one, so we did the 145. We can do it for 46. 18 plus 340 times 46. When you calculate that, that's 174.40. Again, that's a dollar amount. When we calculate 47, we're going to drop that 47 in right here because 47 posters times $3.40 each gives me some amount. And then the flat fee, when we add that in of the 18, that's going to give me 177.8. And then we're going to do this for this last one, 18 plus 3.4 times 48. And so that value is going to be 181.2. Okay. This is my scratch work. This is not my final answer. My question was asking me, what is the reasonable domain and range for this situation? When it says that, it's asking you what are the possible values of x and what are the possible values of y. We just found those. The x can be between 45 and 48. So my x can be this or this or this or this. And my y can be this or this or this or this. That's the only choices. And that's what we calculated. So let's write that out. So we've got domain. It can be 45 posters. It can be 46 posters, 47 posters, or 48. That's what they're going to spend. Or that's how many they're going to buy. And then how much they spend is based on how many they buy. So my range is how much they're spending. The lowest amount they're going to spend is $171. They can also spend 174.4. They can spend 177.8, or they can spend 181.2. Those are the only choices. Okay. If I put a pink box around it, this is the answer to this problem. Everything else was scratch work getting ready to answer this. Okay, we had to do the math in order to be able to know exactly what the range values were. So with this particular problem, let's think about what's happening. We have a 12-gallon aquarium and it is leaking, which means we're losing water at the rate, that sounds like a slope to me, a rate that's 0.75 gallons per minute. What is a reasonable domain and range for this situation if it leaks until it's empty? Okay, so I'm going to kind of think about this for a moment. First, I want to decide, is this a continuous or a discrete function? And this is going to be continuous because when you're leaking, you can leak for a few seconds or a whole minute or 1.5 minutes. Like it can leak until it's empty. So this is going to be a continuous function, which means what we need to do is we need to figure out what our starting values are and then what we're going to end up with. Okay. And there's two things that we're looking at here. We see gallons and minutes. Okay. Minutes is typically going to be our X value. Okay. That's going to be time. And so we're measuring that in minutes here. So I can think about my starting time and my ending time. Well, it starts at 0 minutes, right? It's, that's when it starts leaking. It does not tell me what my end time is, and that's okay. We can calculate that. Let's look at our other value. So our other value is gallons. That's a volume. And so we can measure that. That's Y. We measure that in gallons. So as time goes on, the volume will decrease. And so at the very beginning, before it started doing any leaking whatsoever, it's at 12 gallons. Okay, it's at 12 gallons, and it's going to go until it is empty. And if it's empty, it's going to end up at 0 gallons. So then our dilemma is, how do we figure out how many minutes it took to get to empty? Well, the clue is this. It gave us 12 gallons and 0.75 gallons per minute and that it's leaking. So we need to write an equation. So my equation that I'm going to use is going to be, I'm just going to write me a simple linear equation. My y, which is my volume, we can say that, it starts at 12. That would be my y-intercept. It's starting at 12, but it's leaking, so I put a negative there, 0.75 gallons per minute. Okay. So we can figure out what x is if we take a value of the volume here. If we want to know how much time has gone by, we can plug that volume in here for y, and it's going to tell us how many minutes it took to get there. So let's do a little bit of math. We got my z. Oops, I did not mean to do that. I do that every video, it seems. Try again, do over. Okay, so I am going to put in 0 as my y, negative 0.75x. X is my time. That's what we're looking for. And then it started out with 12 gallons. All right, so I got to have something on this other side. So I'm just going to move this 12 over. So I'm going to subtract 12 from both sides. That cancels. I get negative 0.75x equals negative 12. I can divide by negative 0.75 on both sides. And that cancels. And so negative 12 divided by negative 0.75, as it turns out, is 16. And that means 16 minutes in this case. Okay, so my end time is going to be 16 minutes. It tells me that it took 16 minutes for that to completely drain. Now that we have done all of this work, I can go ahead and write my domain and range. So my domain, because this is a continuous function, I'm going to write it, like, this here. Because it's a continuous function, I'm going to write it with inequalities. So my domain, the low value was 0 minutes. The high value is 16 minutes because I just calculated that, right? So my 0 is given. I just calculated 16. This is all my possible x values. The time can exactly equal 0, and it can exactly equal 16. So this inequality is showing me my x is going to be somewhere between 0 minutes and 16 minutes. My range is all the possible values for y. Okay. I'm going to put my lowest value of y, which is 0 gallons. That's the absolute lowest it can be. The absolute highest it can be is 12 gallons. My range is y, so I'm going to put y in there. And it can be exactly equal to 0 and exactly equal to 12. I'm going to draw a pink box around it. This pink box represents the answer to what the question was asking. Everything else is the scratch work. All of this is the getting ready to answer, okay? Because the actual question is, what is a domain and range for this situation? So my domain, it took from 0 to 16 minutes to drain. And my range, the 12 gallons, the lowest amount of gallons was 0 and the highest was 12. I hope that helps, guys. Until next time, bye.